Now that we've had a chance to explore some of the fundamental concepts behind Realflow, now let's start to take some of these tools and some of these concepts and start to make a small project out of this. So the first project of this kit will be filling a small glass with just some water. Okay, so one of the things to remember whenever you're working in Realflow is, again, this really isn't a modeling program. So any geometry that you want to be able to use in your simulations, that geometry needs to be built in another 3D application, whether that be XSI or Maya or Studio Max. Really doesn't matter. Realflow's pretty good about taking most common geometry types. So what we can do is just go to our Geometry tab, and let's go ahead and import an object. Okay, and the object that I'm going to import is just this water cup, and I have it in an OBJ format. You also have the ability within Lightwave to import these other file formats. So I'm going to go ahead and import this water cup. Okay, and here's the cup that I import. Now, one thing that you also need to keep in mind within Realflow is that any geometry that you import needs to be a triangulated polygon object. Okay, that's really about the only type of geometry that Realflow can accept without any problems, is a triangulated polygon object. Okay, so we have our cup within our scene. Okay, now let's go ahead and start to add an emitter to this. So if I drop in my circle emitter, okay, you can see that my circle emitter is very, very small. Okay, it's really not so much that the circle emitter is small, it's that this cup is really big. Now, within Realflow, Realflow's dynamics are based on real-world geometry. So looking at this, each one of these different squares is 1 meter in length. So when you consider that the average person is, just a little over 2 meters in length, you look at this, and this glass is really not really a glass at all. It's really about the size of a swimming pool. So trying to fill this up with water is really going to be tough. Now within Realflow, you have a couple of options that you can do at this point. You can either scale your object down by just setting its scale a little lower. That, though, becomes pretty problematic, especially when it comes time to go back to your original 3D program. Now your geometry is going to be much smaller. The other option that we have is to adjust the scene scale. Now the scene scale doesn't necessarily adjust the size of your object, just the size of the scale of your overall scene. So by default it's going to be set to 1. Now if I wanted to set this to something more manageable, like something 1/100th of that size, and then if I were to look at this, now if you consider the fact that we're looking at something that's 2 meters in length, okay, now this glass is probably about the right size if we wanted to have something that's physically size accurate. Although by simply adjusting the scene scale, though, we really haven't adjusted the size of this object itself. Because if I were to select this object, its scale is still set to 1. So when I import this back into my 3D app that I originally came from, which was Maya, it's still going to come back in at the original size that it was when I exported it. So we're good there. There is, though, another issue, and that is that Realflow has problems with both very large scale scenes, which was what we had before, so very large scale scenes like this. It also has some issues with very small scale scenes, like this. Okay, so what do? We're probably going to have to just find a happy medium. So let's work up to a little smaller, or a little larger number, 0.5, 0.08. 0.08 might be a little better. Okay, and I'll probably need to adjust the size of my emitter just a little bit. So let's try something like that. Okay, so let's go ahead and simulate this. And it looks like I'm going to need a lot more particles, because if you recall, the rate of your particle emission is very dependent on the size of your emitter. So by making our emitter quite a bit smaller, we're going to have to counteract that by giving this a lot more particles. So this resolution of 1, let's see what happens if we were to take this up to something like 20. Go ahead and simulate this. Now we've got more particles, which is what we would want. So probably going to have to take this up even higher. So there we go. Now we've got a decent amount of particles. The thing that we're probably going to have to keep in mind, though, is for something like water, we're really going to need a lot of particles for this to be an accurate simulation. So we'll probably definitely have to take this resolution up quite a bit higher. So we're going to have a lot more particles, which is going to be more difficult and more time-consuming to actually simulate, but it should come out much more accurate. So here's the amount of particles that we're actually getting out now. Okay, not too bad. And just to shake things up a little bit, I'm going to go ahead and rotate this off to the side just so that our water's not coming straight down. And I'm going to go ahead and switch this to a global axis mode and just pull this over. And I'll go ahead and add a little bit of gravity. So now our water can actually fall down realistically. And I'll simulate this for just a second just to make sure that our water is actually coming down into the glass. Okay, so it looks like the water's going to be okay. Now before I finish off this lesson, let's go ahead and use the relationship, or the scene tree, and let's go ahead and connect this water cup into this circle emitter. So I'm going to go ahead and just click, drag this over, so now I've connected the water cup. Okay, so hopefully, now when I simulate this, we should have now some collision that's happening between the glass and the water, so that now this water is actually filling up this glass. So you can see now that as these water particles start to get closer and closer to this glass, that our simulation definitely does slow down quite a bit. So if I were to simulate this through, you can see now we actually have some decent water that's flowing through here. So in the next lesson, we'll go ahead and continue building on to this simulation.